In the last video you saw the tension test for low carbon steel. Today we are going to show you the tension test for aluminium. And the specimen which I have today looks like this. It has cylindrical heads, so we need the V-grooved grips today, and I'm going to show you in a minute. So the setup remains the same like the last experiments. The only thing which changes is the grips. So if you see the grips over here, you can see that it's V-grooved, and it's for a purpose so that it can fit this specimen very easily. So again the same thing, so we are going to go ahead and place the specimen over here and make sure that it's secure. So make sure that it's secure in place. Next I'm going to connect the upper part as a okay. So what we are going to do over here is we are going to, before we put the specimen in inside, we are going to make sure that there is enough space, and it's going to make sure. And then I'm going to go ahead and measure the cross section for the specimen, which should be, let's see, which should be around, it is, let me go ahead and re-zero it again, and it's around 6.4 millimeters, okay, the cross section. So let me go ahead and around 0.25 inch. See how much it will be in inches. So it's around 0.25 inches. Okay. So once that is done, so what we are going to do is the same thing. We are going to go ahead and make sure that my specimen is secure. So I'm just going to try to secure the specimen, secure the base first, and then secure the top. You can see that our specimen is secure. So now what I'm going to do is, like I told you last time, we are going to also attach the extensometer over here. But before I do that, I'm just going to quickly show you the load on the screen. So you can see that my specimen is secure into place, but if I see the load, it's not 0, it's 736. So this is the same, this load is due to the same reason, the preload factors or the residual loads inside the specimen, and you have to take care it the same way as you would do for the other metal. Okay, so our specimen is fixed. Now what I'm going to do is I'm going to go ahead and place my extensometer. So same way, so I'm going to go ahead and touch the extensometer. Make sure that the grip is connected properly. It's near the middle part of the specimen is near the middle region of the grip over here, this flat, tiny flat part. Okay. So I'll make sure that it's totally not stretched. Okay, once that is done, the experiment is ready. Just going to make sure that our extensometer reads 0. I'm just going to go ahead and re-zero it once like we did the last time. So it's re-zeroed now, and then I'm going to go ahead and start the test. Okay, so please observe as I start the test. So you can see that the extensometer grip gauge length is at 1 inch. So our extensometer gauge length is also at 1 inch. Okay, so we are all set to start the experiment. Now what we are going to do is I'm just going to go ahead and take my marker over here, and I'm just going to place I'm going to draw a line over here, and I'm going to draw a line in the bottom. So that's going to help me to visualize how much maximum strain there is in the specimen, or how much the specimen got elongated by. Okay, so I am all set. I'm going to go ahead and click play and let the experiment begin. Okay, so this part is moving upward, so basically it's creating a stretch, and slowly you're going to see that the load will increase on the computer. And again, mind you that there will be a pop-up asking you that the extensometer should be removed. So whenever you see that pop-up on the screen, go ahead and hit the play button right away, or else it might damage the extensometer. So we're gonna have to wait a little bit, but the pop-up can come up any minute. So once you see that, I'm just gonna go ahead and hit pause, I'm sorry. So once you hit pause, the experiment is paused. So now go ahead and write down your extensometer reading. You can see it on the screen, and I'm gonna go ahead and take it off. So I took off my extensometer. Now what I'm gonna do is I'm gonna start my experiment once again by hitting the play button. So it's gonna resume from where it stopped. So now you can see that there is a neck over here. It's kind of getting dented, but you can see that the neck will get more and more pronounced as the test progresses. Okay, so you can see that there is a dent. So, and that means that the specimen has fractured, and we are to the end of our experiment. So once your experiment is done, go ahead and untie your specimen. So I'm gonna go ahead and open this. So you can see that this is my specimen after the experiment. So I can show you by comparing it to a brand new specimen. You can see that how much it has elongated by. So you can see this. Let me try to hold it over here. You can kind of see that how much the specimen got stretched by. So your next step will be to take the vernier caliper once again and measure the cross-sectional, measure the diameter over here near the fracture zone, and just note it down so that you have a qualitative comparison of the diameters before and after experiment. So once that is done, export the raw data like you did before. And so I'm just going to show you once again. So this is my current test, which is test 4. Make sure you click on that, hit export raw data, save where you need to. So I'm just going to save it at the desktop and click OK, and then click OK again. So this will save my data. I'm just going to go ahead and show you how to open it. So just open it, and you can see your raw data. Okay, so once that is done, your experiment should be complete.